Studies have shown that inhalation of welding fumes causes respiratory damage and chronic health effects. As such, long-term exposure assessments are important to ensure welders can work in a healthy environment. This is especially the case with shipyard welders, who have some of the highest industry risks amongst welders of developing cancer. A study conducted in Taiwan revealed the need for better control measures for shipyard welders, such as mobile local exhaust ventilation systems and respiratory protective equipment. The study focused on the metal concentrations in welding fumes in the near field, which is the surrounding work area and the welder's breathing zone, and the far field, which is the rest of the facility. Here are the chosen 8-hour occupational exposure limits used by the study. As a note, these occupational exposure limits differ from OSHA USA's. Exposure ratings were also assigned at set intervals corresponding to the study's occupational exposure limits. Each of these exposure ratings had a recommended control action associated with them. The study utilized simulation, predictive models, and real-world measurements in active shipbuilding facilities. In both cases, iron and manganese exhibited the highest emission. The study also found that welders' long-term exposure to iron, manganese, and lead is likely to exceed the operational exposure limits chosen by the study. Near-field emission rates of iron, manganese, and lead were highly likely to enter ER4, which recommends implementing respirators and work practice control. Iron had a 52.2% probability of entering ER4, while manganese had a 25.4% probability, and lead at 0.1% probability. Chromium, iron, and manganese also had a high probability of entering ER3, which recommends controls including exposure surveillance, medical surveillance, and work practices. Chromium had an 83% probability of entering ER3, while iron had a 48.8% probability, and manganese had a 74.6% probability. Far-field rate probabilities, which encompass the rest of the building, had all metals at ER3, except for nickel. The study concluded that. Therefore, the shipyard manufacturing industry should take appropriate control measures, such as installing a mobile local exhaust ventilation system, and providing suitable respiratory protective equipment for welders. And further, it is concluded that preventive measures should be taken for reducing welders' exposures immediately. One effective solution is the installation of mobile or portable local exhaust ventilation systems. These systems help capture and filter contaminants at the source, reducing the air's overall concentration of hazardous particles. Additionally, providing welders with suitable personal respiratory equipment, such as full-face respirators with proper filters, can help prevent the inhalation of harmful fumes. The introduction of human-operated robotic welding to the shipbuilding industry has lowered worker exposure in near-field regions, though adequate local exhaust ventilation and facility-wide filtration are still recommended to prevent secondary exposure. Robotic welding cells can utilize fume hoods to contain, capture, and filter contaminated air. Facility-wide ventilation may also be desirable to ensure the safety of everyone in the building. Finally, the study's chosen occupation exposure limits differ from OSHA permissible exposure limits in the US and those of OSHA Taiwan. The limits used in the study are generally higher, which is concerning when the results are adjusted to OSHA limits. While the welding process and conditions in Taiwan may differ from North America, the field measurement techniques and simulations used by the study do offer an interesting starting point for conducting similar studies in North America or measuring concentrations in the field to ensure OSHA compliance.